I am Ramprakash. I am a senior professor here at IUCAA. I am the head of the instrumentation lab. I am sitting in one of the rooms of the instrumentation lab here, where I did my PhD as a student more than 30 years ago. These labs were established by Professor Shyam Tandon at the same time as IUCAA was established, and over the last 2 or 3 decades, the facility has grown multi-pronged. Its activities have grown substantially, and I will try to give you a glimpse of what all we do in these labs. There are 2 aspects of the activities which we have in this IUCAA's instrumentation lab. One is development of core technologies for astronomy and astrophysics, because astronomy is observation driven science, and for carrying out those observations you need various kinds of equipments like telescopes, spectrographs, cameras, polarimeters, etc., both ground based and space based. So, for these technologies, these facilities, the new technologies have to be developed. As technologies become available, new technologies develop, we have to explore all the time how those technologies can be put into use for applications in astronomy and astrophysics. So, we emphasize on 3 areas in technology development. The first one is developing high precision controllers for sensors in astronomy, various kinds of sensors, but primarily CCD, CMOS, infrared, detector arrays and other kind of sensors. These are crucial for these are the light sensing elements in telescopes and instruments, and controlling them, the electronics required to controlling them are being developed in IUCAA. We also work on applications of optical fibers for astronomy. For example, to bring capabilities of 2D spectroscopy or hyperspectroscopy in astronomy, by which you can map an entire region of the sky and get the spectrum for that entire region in one go. Highly multiplexed hyperspectroscopic applications using optical fibers and other techniques. We also develop techniques for adaptive optics in astronomy and astrophysics, where when light passes through the atmosphere, it gets distorted because of turbulence in the atmosphere, and the adaptive optic systems measure this turbulence and in real time correct for it, so that images can be produced as if the facility is sitting in space without the defocusing or blurring effects of the atmosphere. So, these are some of the technologies we develop in this place in the instrumentation lab at IUCAA. We also build full-fledged instruments, starting from design concept all the way from the full-fledged design, detailed design, then actual fabrication of the components, assembling and testing them together, and then deploying them on facilities like telescopes, observatories, etc., and then reap the benefits of science. So, we do end-to-end instrument development programs also. We have in this lab several instruments have been designed and developed, starting from imaging polarimeter, which was my PhD program more than 30 years ago. But more recently, we have developed instruments like RoboAO, a robotic adaptive optic system which works autonomously on small telescopes to correct for atmospheric deblurring. We also have developed something called RoboPole, which is a polarimeter in collaboration with a set of partners in Greece, in US and South Africa, etc. We have recently been involved in some space activities. It started with AstroSat, where the UVIT instrument was built in collaboration with Indian Institute of Astrophysics by Professor Shyam Tandon and his team. And then more recently on the Aditya L1 mission, we have built the solar ultraviolet imaging telescope, which has recently been launched by ISRO, and it has reached the Lagrangian point L1 between the sun and earth, and has just started observing the sun. So, these are a set of instruments we have built in the recent past. We are also working on other new instrumentation like a very wide field polarimeter, which will measure the 3D tomographic structure of the galactic magnetic fields and the dust distribution in the galaxy at high galactic latitudes, which would be a very gold mine of data, which has never been attempted before. And these two instruments will be established one in the northern hemisphere in Greece and one in the southern hemisphere in South Africa, so that both the galactic north and south poles can be simultaneously observed to conduct a very large survey, which will last about 4 to 5 years. So, there are these instruments which we built. Also, the technologies we use or develop are applicable or find many applications in fields outside astronomy. As an example, we have recently concluded a collaboration, a consultancy work with CDAC, where we help them develop industrial smart sensor cameras, which can be used for various kinds of industrial applications. We also worked with them to develop infrared thermal imaging system for road traffic monitoring applications, and these two have just completed, and the technology transfer has recently taken place to some of the first industries that would use these technologies and these cameras for multiple applications. So, our activities in astronomy and astrophysics are now beginning to find applications beyond the limits of astronomy and into the wider domains of society and other fields. Thank you very much.